Excited about because I brought all these dice here and I want you guys to know how to play. It's a tabletop game where you need at least 2 people and cups that you can't see through and 5 dice for each person. So we would all sit around this table, suppose there's 4 of us. And at a high level, I just wanted to step back and say, the game is going to proceed in rounds. Each person starts with 5 dice. And at the end of each round, there's going to be a loser for that round. And that person loses 1 die from their cup. If you lose all your dice, you're out of the game. And the goal is to be the last person standing with any dice remaining. So what actually happens during these rounds? We each take up our cups of 5 dice, and go like this, and we see what we have. And it's going to look something like this. We're each going to have 5 dice that only we can see. Some terminology, the dice number face is the digit, so the digits are 1 through 6. And the table count per digit is the number of dice of a particular digit that are on the table in total. So here I've written them out for this scenario. For the 1s, there's 4 1s. 1, 2, 3, 4. And for the 2s, there's 5 of those. 1, 2, 3, 4, 5. So each digit has a table count. And I can only see, if I'm him, I can only see what I have. So if I'm going first in this round, I have to make a claim about how many dice of a particular digit there are on the table. What's the table count for a particular digit? And I can make up whatever I want. I'll say, I think there's 3 4s. So the next person in the rotation, clockwise, is going to say, they have 2 options. They could say, bullshit, I don't think there's 3 4s. Let's all pick up our cups and see how many we have, and we'll see who is right. Either I'll be right, there are at least 3 4s, or she'll be right, there are less than 3 4s. Whoever's right wins, and the other person loses a die, and that round's over. And the person who won that little showdown goes first next. She doesn't have to say, bullshit. Instead, she can up the ante or make a bolder claim about what's on the table. But there's rules as to how she can make those claims. So she has to increase either the digit or the count. So if I said that there's 3 4s, she can say that there's 4 4s, or she can say that there's 3 5s or 3 6s. Or she can do both. She could say, I think there's like 4 6s. If I say there's 3 6s, what are her options of what she can say next?
Only 4 6.
4 of anything. She can't go up any higher in terms of the digit. She can only increase the count. So that's the rule about how, and so as a result, the claims get bolder and bolder, and eventually it becomes unbelievable that the table count would be so high, given that there's only 20 dice on the table. So someone's going to be like, bullshit, and there will be a showdown, and one person will lose a die. Now, there's one other rule that you need to know, which is that 1s are actually wild. So that kind of changes the math in terms of figuring out the expected number of dice on the table, given that you only have partial information of your own dice. The last rule is that if you start with 1s, 1s are no longer wild. You don't need to worry too much about that right now. It's a minor detail. But the key is that 1s are wild, and that changes the strategy. Go ahead.
What do you mean 1s are wild?
Oh, good point. So when calculating the table count for 2s, I count up not just the 2s, but also the 1s. So the table count for 2s is now 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So just quick strategy. If you want to figure out the expected number of any given digit on the table, you would say, well, how many dice do I not know? And you would say, well, for all the digits 2 through 6, there's a 1/3 chance that it's either that digit or a 1. So if there's 15 dice that I don't know, I would divide by 3 and say there's 5 of any digit plus my own, and that's my best guess. But then the psychology comes in, which is next week.